Hey, welcome. Good to be back. Here we are. Hey, and before we start, I will shortly excuse Heiko and explain why, for the first time, I'm saying the first hello here. It's that time
Yeah,
of the year when all of us discover there are more viruses than COVID around. So, and he was just keen to try one of them. So, Heiko, maybe say hello.
yeah. Not sure I caught. It's not Corona, but yeah, my throat is a bit sore, so excuse my voice. I'm being a little rough today. Didn't want to miss the event though and leave Jan in alone here. So
Thanks.
let's make it through the session. Excited to get into the artificial intelligence, maybe helping us out to understand how could I have avoided catching whatever other infection that is now. Yeah, I don't know. Session number 6, Jan. Tech Up number 6. Do you believe it?
Now, who would have thought that when we first held the event online in March 2021, right? And actually, this is kind of a flashback because the first session was about AI and ML as well. Yeah, so that's it's kind of
Absolutely, yeah.
nice. Yeah?
And we still use the digital way of streaming this to the world and have not had the chance to meet in person, right?
Absolutely true. Yeah, but it looks like might be something next year in Karlsruhe. Let's see. Yeah,
We,
but
we will see, yeah. But we'll probably, we don't want to miss the chance to keep this a hybrid event. It's really cool how we have so many guests from different parts of the world. We're streaming across 3 different platforms at the same time. And yeah, it's a bit trendy right now. We are on Twitter, all right?
no,
Until
yeah.
we might get
Well,
banned. I
let's
don't
see.
know. I didn't verify my account on Twitter, but it's the official company account that should work. We're on
Yeah, I
YouTube
heard.
and we're on LinkedIn.
Yeah, I heard like verified accounts are giving a lot of information, but not the real one, right?
Yeah.
But hey,
And
yeah.
yeah, you wonder about us speaking in English today. Some of you who may have joined the sessions before, first time in English. We have an international speaker. Really honored
Yep.
to welcome him to the event today. So we decided to open this up to the international community, do it in all English, and hopefully reach some guests that otherwise would not have been able to join, like in the past previous events when we were speaking German.
Absolutely. So, let's find out if this works. Like this is one platform that streams to 3 different platforms, so YouTube, LinkedIn, and Twitter. So it will be really interesting. We should get the feedback from all of you back here from all of these platforms. Unfortunately, it can't be read from one to the other, but it will be really interesting to see from where are you from and from which platform you are watching.
Yeah, so
So
post us a note. Where are you at? We have a slight time difference here, but it's going to be nice to see. We have some interesting chat messages coming up, of course.
all right. So then I think we talked enough here. We'll dive into the session then. So welcome together all. Today's Tech Up is about how AI and ML are changing our lives. And waiting for the slides to come up here.
Yeah, I think we have to pull up the presentation. A little note to our colleagues in the background doing all the hard work while we just sit here and chat. Yeah, it seems to be some technical issues. But hey, I'm looking at some of the chat messages coming in.
Yeah,
We have a guest
wonderful.
from Scotland, someone from Guatemala City. That's fantastic. So
Palm
hope
Beach.
you all
I'd
have a
love to be
good
there
time
at the
out there.
moment.
Philadelphia on LinkedIn, an American who speaks German. Yeah, we'll stick with English still. Someone from Berlin.
Nice.
Great to see you all there. So really nice to see the international spread here. And as we wait for our little presentation to show up in the background, should we just, yeah, you know what's written on there, so we could just do it as well.
That's true. I'll just continue. So, as Stephen Hawkins once said, the quote was, "AI is probably the best or the worst thing that can happen to humanity." We did do some research where this actually originally come from, right? Like the background information is Web Summit in Lisbon. So Stephen Hawking warning about artificial intelligence that develops a mind of its own. So that's fun.
Yeah,
Yeah.
and it's an interesting quote for sure. But at the same time, like any technology, AI in general is morally neutral, right? So we have to find a way to deal with it. And I think we are pulling up the slides.
There we go.
Perfect. Because we have this quote in big letters, of course, to see.
Yeah.
Let's move to the next one. Very good. There it is once again. All right. And of course, we don't just want to show quotes from important people. We want to actually dig into the real AI and ML. We have some great guests today. But before we start, Jan, maybe a quick introduction, especially for those who have not joined before and wonder who are those two guys chatting around.
So hopefully next slide, and then Heiko. Yep, the two of us.
Yeah, so my name is Heiko. I'm a little infected with some cold today. Manage the agency and developer program at IONOS. Some of you may know me from the agency partner program and work with us. I've been with the company for about 10 years now. It's been a long time. Formally started under our old name, 1&1. A few years ago, we introduced the brand IONOS, and hopefully you all have heard of IONOS by now. Okay, then I'll continue. My name is Jan Friebe, as states here, and I've been with the company slightly longer, 21 years now. And in my current role, I'm in charge of a software development unit, which actually takes care of all of our orders. So if you're a customer with us, you will probably have gone through my system, and I will make sure that whatever you've ordered or wished for is executed and orchestrated in our landscape. And and the last thing I probably do is what you don't like that much, I'll activate in the billing and say they can send you an invoice. Yeah, that makes you the most liked person in the company, of course, Jan. And probably. I'm always impressed. 21 years, that's just a really, really impressive time. So let's look at who we have today. So after this short welcome, we'll be over in just a minute. We will have Julien Simon from Hugging Face, a really well-known person in the AI and machine learning world, joining us today with his talk. Absolutely, and it's Oliver Hessel from IONOS, one of our colleagues, and Sönke Liebau, and they're both joining together for a joint talk about big data infrastructure, and that'll be very interesting to see how you can get the AI live and also live on our system. So I'm really looking forward to that, yeah. And as you used to, we'll have a small panel discussion at the end. We'll ask some challenging questions to the experts that are joining us today, and I'm really looking forward to that. But before we start, just one last reminder. We would really appreciate if you do a little social media promotion for us as well. If you like what you do or like what you hear, give us a tweet or a post on LinkedIn. You can use the hashtag IONOS Tech Up. Put any questions, suggestions, etc. that you have into the chat, whichever tool you use. It will show up right here. And of course, at the end, if there's something that comes up, feel free to send us an email to techup@ionos.de. But use the chat function if you want to bring it into the conversation here. Absolutely. You can help us a little bit if you ask questions, because this is not just about us, but it's actually you getting in touch with the experts here. So, when you like what you see and you have a question for what you see to one of the presenters, it will really help us and in the back end to group it by, maybe whom you want to address this question to. So just maybe write name, Julien, and then your question, because then we can bring it up and, place it correctly. That will just help us. Yeah. And I'm looking at the messages coming in. So because you cannot see any message that comes from another tool that you're using. So just to let you share that as well. So we have someone calling in from Magdeburg in Germany, Dortmund from Hamburg, obviously a few visitors from Karlsruhe as well. United States, Scotland, Romania. That is really impressive. So thanks everyone for joining us today. And I would say enough for the chit chat now, Jan. Let's get started. Absolutely, yeah. So we're really excited to share with you our great new speaker. Maybe bring him up to our stage here and welcome Julien. Hi.
Hi, everybody.
Was that pronounced correctly? Julien, right?
Yeah, it doesn't matter.
It doesn't matter. I was wondering. I was like, okay.
Well, it's a French name, but we pronounce it in the English way.
Well, but I'm pretty terrible with German names as well. So I think
okay,
I can butcher German names just as well. So that's fine. Julien will be just fine.
Feel free to butcher mine. That's fair.
Oh, I will.
Very good. Okay, you've actually spent 6 years at Amazon Web Services. That's what we kind of found out. Correct us if we're wrong. You were a global technical evangelist for AI and machine learning there before joining the AVS. You spent years in the CTO and VP positions in engineering in large startups. Is that right?
Yeah, I had a few previous lives.
Cool.
Yeah.
Yeah,
and you are certainly a celebrity, so
I don't know.
thanks for joining us today.
It's a pleasure. It's my job is really to help people understand what the technology can do. I was doing that at AWS, and I'm happy to do it at Hugging Face now, and try to keep it simple, keep it practical, and hopefully everybody can go home or go back to the office with some new knowledge that they can use to build cool stuff. And
wow,
if we achieve that, then I'm happy. So
very cool.
Wonderful.
And we do have about 300,000 viewers in this stream now. So
at
obviously
minimum.
the promotion,
the
promotion worked. So no reason to get nervous. I would say, Jan, let's hand it over to Julien.
Absolutely,
to hear you talk.
Sure. So let me share my screen and we'll just get started. Okay. All right. So can you see my screen now? Yep. Just checking. Okay. All right. Yeah. Is it my screen or is it the deck? Just checking. It looks like it's the deck. Okay. Can I share my screen instead? Because I need to do some demos. Let me do that. Okay. Yes, that looks better. All right. Okay. So now you're seeing my slides. So what I like to do in the next 30 minutes or so is to give you an introduction to, of course, Hugging Face and what we're doing, but I think more importantly on transformer models and why they're changing the way we're doing machine learning today, and particularly deep learning. So, as you probably know, deep learning started in the enterprise world around 2014, 2015, when neural networks, really old technology, was resurrected and brought back to life and applied to a wide range of use cases like natural language processing, computer vision, and speech, and additional things. And of course, back then, ML engineers and data scientists would build their own neural networks using traditional architectures like convolutional neural networks or recurrent neural networks and so on. And that, of course, that was a very significant effort, and it required a lot of deep expertise on how to build those networks, and of course on the tooling required to do that. So definitely not for everybody. Another major effort that was needed was to collect and label and build large data sets. Because as you know, deep learning is very data hungry. You need to feed potentially hundreds of thousands or even millions of samples to a model so that it can learn how to extract the patterns from the data. And in order to do that, you need to have a clean labeled data set that's ready to go, whether it's text or images. It's a huge effort, and data scientists and data teams routinely spend 50 to 80% of their time doing that, which is a shame because although it's important work, it's more important to spend time on the model and optimizing its performance instead of just accessing and cleaning data. So putting the two together, neural networks and data sets, teams used GPUs, which actually enabled this deep learning revolution, thanks to their massively parallel architecture. And so neural networks plus data sets training on GPUs is what gave us those amazing first deep learning models. Although this created challenges because for a long time it was pretty difficult to get your hands on those high-end GPUs. You could get gaming GPUs or consumer GPUs, but for machine learning it was very difficult to get the access to the really good stuff. And if you could get access to it, it was extremely expensive. So that situation has changed a little bit now. But still, scaling on GPUs was never a very cost-effective and simple proposition. And the bigger problem, honestly, was that to do all of that, you really need expert tools. So from frameworks to data processing tools to GPU environments, everything was just very difficult to set up and build with. And again, that meant you really needed to have a deep background in machine learning and data science and machine learning engineering to get to the end of the whole process. And so this was really reserved for companies who had the time and budget and skills to jump through all those hoops, meaning that for a lot of companies and organizations out there, this was just out of reach. And so they probably did not use deep learning at all, or they used some off-the-shelf AI services that didn't necessarily fit their purpose. So that's really what we're trying to improve on. And we're calling it Deep Learning 2.0. We'll see. Maybe that ends up being 1.1, but we think it's still a nice improvement. So the first improvement is the emergence of a new architecture for neural networks called transformers. And transformer models are not only extremely accurate on a variety of use cases, they also have a standard architecture. And that's good news, because instead of having to cherry pick a particular architecture for a particular use case, we can now standardize our machine learning efforts on the transformer architecture. And that just simplifies everything. An additional benefit of transformer models is that they work very well with transfer learning. So transfer learning is a technique where instead of starting from a blank model, models that hasn't been trained at all, we start from a model that's already been trained by experts on a huge quantity of data. Think, Wikipedia for text models, or millions and millions of images for computer vision models. And so those models can already do text classification, image classification, image segmentation, and so on. And you can use them as is. So you can just download them, use them in a couple of lines of code, apply them to your own data. And if they work, then great. That's it. You're done, right? So you have this huge collection of models that are waiting for you and waiting for your projects. And it's in the case, for example, of, let's say, text translation models, or sentiment analysis model, or summarization models. These are generally very good, and unless you have very domain-specific data, you can use them right away with no training at all. So that's a huge time saver. Obviously, in some cases, if you have very domain-specific data, let's say chemical engineering or genomics, or working with complex legal documents, you may want to train those models just a little bit more so that they understand all the nuances in your domain. And this process is called fine-tuning, and it's generally, 10x, 100x, maybe more, faster and simpler than training from scratch. So you just need a little bit of data, a little bit of compute time, and you can customize those pre-trained models for your own domain. So you can just go much faster than before, because you don't have to build a huge data set and you don't have to train on it. Speaking of which, now we have alternatives to GPUs. So GPUs are still nice, they're still useful, but some companies like GraphCore, Habana Labs, Intel are innovating and building chips and hardware features that help accelerate training and inference for deep learning models. And so now, instead of going to GPUs by default, which is like I said, a complex and sometimes expensive proposition, especially for smaller models and some smaller workloads. Now we can pick whatever architecture works best. Okay, so we can train with a better cost performance ratio. We can predict with a better cost performance ratio, and these are great news because we can just pick the option that works best for us. And last but not least, we can do all of this with developer tools, such as the tools that Hugging Face builds. And the emphasis here is really on developers. You don't need to be a machine learning expert. You don't need to have deep knowledge on neural networks and statistics and computer science. You can work with those models in just a few lines of code and build your POC and maybe even your project with those simple tools and simple techniques. Okay, and we'll see some examples. So let's zoom in maybe a little bit on transformers, because those are really the most transformative models today. So I guess 2022 is really the year of transformers. We see the traditional architectures like CNNs, LSTMs, RNNs gradually losing ground, and not a week goes by without a new transformer model advancing the state of the art and improving the benchmarks for NLP, computer vision, speech, etc. And it all started around 2018 with Google BERT, which you've certainly heard about. And again, lots of models have followed, coming from research organizations and large companies and individuals, etc. And again, this is really a really rich world. And every week we see new amazing models coming out. This was picked up by industry reports. The State of AI report, the Kaggle Data Science Survey last year showed that transformers were really becoming a general purpose architecture, replacing other architectures. And in fact, in the 2022 State of AI report, this slide caught my eye. What we see here is the modalities for transformer usage in research papers in 2020, 2021, and 2022. And it's interesting to look at research papers because it gives us kind of an advance warning on what's going to end up in production in the next months and next years. So 2 years ago, transformers were really only used for text, right? And that makes sense because, again, models like BERT and the original transformers were trained on the NLP workloads. Computer vision was almost non-existent. Moving forward 2 years, we see NLP is still the bigger chunk, 41%, but it's actually less than half of the use cases. And we see a very fast rise in image use cases, and that's because in the last year we've seen some amazing transformer models coming out for image workloads like the Google Vision Transformer or Microsoft Swin and others. So obviously these are being put to good use. So we see it's more balanced now. Still a lot of NLP, but a lot of image, some audio and video, and multimodal use cases where we mix text and images or text and speech, etc. And we'll see some examples. So what about Hugging Face? Hugging Face is a company that was started in 2016, and it's the steward of different open source projects. The most popular is the Transformers library, which lets you work with all those state-of-the-art models in just a couple of lines of code. And this is actually one of the fastest growing open source projects in history. If we look at the GitHub stars on this slide, we see that, of course, Hugging Face is the blue line on the left. And it's been consistently growing faster than amazing projects like PyTorch or Keras or Spark. And it's even growing faster than Kubernetes, which is really crazy when you think of the popularity of that project these days. So that tells us we have a lot of adoption, we have a lot of traction, it's not slowing down. And this means transformers and the other open source libraries by Hugging Face are solving problems for developers and machine learning engineers out there. Hugging Face also maintains a website called the Hugging Face Hub. People call it the GitHub of machine learning. I think it's a fair analogy. Just like you go to GitHub to find code and share code, you go to the Hugging Face Hub to find and share models and data sets. So I've completely abandoned the idea of keeping this this screenshot up to date. It's only a few, maybe a couple of months old, and it's at 72,000 models. When I updated it a few days ago, it was 85,000, and something tells me we're really close, or maybe we've passed the 90,000 model mark. We're adding about 500 models every single day right now. And so those models are off-the-shelf pre-trained models for, like I said, natural language processing, computer vision, audio and speech, and reinforcement learning, and additional tasks. We keep adding tasks as they become popular. We also have 13,000 data sets, again, letting you quickly experiment and train models across all those tasks. We have over 10,000 organizations sharing models on the hub, from Google to Microsoft to NVIDIA to Meta to universities and research labs, startups, and individual developers who are training some amazing models that become super popular in 24 hours. So great for them. Day in, day out, we have about 100,000 users, active users on the hub, sometimes much more than that. And we have way more than 1 million model downloads every day. This is a very conservative number, which I should update. So huggingface.co, go check it out. You can sign up in seconds. It's completely free. All those models and data sets are open source, and you can experiment in minutes across a wide range of use cases. So what does that look like? Here's a simple example. You could say this is really Hugging Face 101. Here, it's an NLP use case. It's actually text classification, and more precisely, zero-shot text classification. So text classification, is a very simple use case. Provide some text and get a score for different labels on what the text is about, right? Zero shot is interesting because I can bring any labels. I'm not tied to the labels that are part of the training set. So I could literally score text against any label. So that's very flexible. How do I do this? Well, I import the pipeline object from the transformers library. I create a pipeline for zero-shot classification, just passing the name of a model. Here I'm using a model from Facebook that's been pre-trained on a very large text data set. I select some text. This is actually from Wikipedia here, and I define a list of labels that I want to score against. And just calling the pipeline gives me the scores for each different label, right? So this text is predominantly about finance and science, which sounds about right, given that it's about the Black-Scholes equation. Okay, so it looks like a good classification. So here's really, Hugging Face 101, but things are moving fast, and we also have more complicated task types like text to image, and I'm sure some of you have been experimenting models where you can generate images with a text prompt. How complicated could that be? Well, the models themselves are insanely complicated, as you could expect. But using them with Hugging Face is very simple. In fact, we created a dedicated library called diffusers. And that library lets me create a pipeline in an equally simple fashion, passing the name of the model that I want to use and using a text prompt to generate an image, okay, and saving that image. And this is the particular image that the prompt generated. And I guess we'll agree it's a pretty good image. And you'll have to trust me, I didn't generate 1,000 images and selected the best one. I just ran this maybe 2-3 times, and this is what I got. And it's got all the elements from the text. It's a kind of a desert setting. There's definitely a Corvette. It's parked in front of a diner that looks old school to me. And the lighting here tells me this is this looks like sundown. Could be sunrise, but I'll trust that it is sundown. Okay, so this is again another example of working with bleeding edge models in just a few lines of code without the need for deep machine learning expertise. And stable diffusion is a little bit crazy. You can do different things like in-painting, which means replacing part of an image with something else. So you can draw a mask, black out part of the image, or you can provide a text prompt saying, hey, this is what I did here. Replace a sweater with a Hawaiian shirt. And in just a few seconds of GPU time, this is the image that I get, right? So again, the science and the engineering that powers those models are extremely complex, but if you just want to use them for your business workflows, they're a few lines of code away. We're also trying to advance state-of-the-art. We're not just hosting and serving models. We co-led a huge collaborative project called Big Science with over 1,000 researchers worldwide. And the goal of the project was to train an open alternative to the GPT-3 model, which is not easily accessible to everybody out there. And that effort started with a pretty large text data set and about 3 months of training on about 400 GPUs from a public cluster. And the result was the Bloom model, which is available on Hugging Face. You can go and try it right now for free. You can download it. It's a pretty big model, but you can download it. And if you have the required GPU infrastructure, you can load it on your infrastructure and use it, right? Completely for free. We've launched another project called Big Code, which aims at delivering code generation models, again, that are openly accessible to everybody out there. We're in the process of building the data set now. It's called the Stack. It's 3 terabytes of code in a lot of languages with comments in a lot of natural languages. And if you're interested in the project, if you think you can help, you can go and apply. They're looking for members right now. So can't wait to see what this will look like. So looking at the family picture of Hugging, so to speak, on the right-hand side, we have models and data sets that you can download from the hub in just a couple of lines of code, as you've seen. You can use those models as is, like I showed you in the previous slides, or you can train those models to specialize them on a particular data set. You can do this in a number of ways. You can use AutoTrain, which is our AutoML service. It's completely no code. You only need a few clicks to train NLP or computer vision or tabular data models, and they're automatically pushed to the hub. So they become, normal models on the hub, and you can use them as such. If you want to write code, of course, you can use the Transformers library to download models, fine-tune them, save them, push them back to the hub, etc. And we have other libraries, which I won't go into, but Accelerate lets you do distributed training at scale. Diffusers, we've already seen. Evaluation is about measuring the accuracy of models across data sets with a whole lot of built-in metrics. And Optimum is dedicated to hardware acceleration, and this is where we integrate the work that we do with those hardware companies that I mentioned: Graphcore, Habana Labs, Intel, etc. Spaces is really important to us and to the community. This is really becoming the preferred way to build machine learning demos. We've actually seen some spaces in the previous slides. You just need to write a few lines of code using the Gradio framework or the Streamlit framework, load your model, build a cool UI, and demo your model to the community or to your business stakeholders in a really friendly and business-oriented way, instead of showing them Jupyter notebooks that they probably wouldn't like or understand. When it comes to deployment, of course, you can deploy anywhere. You can grab your model, build your containers, do anything you'd like to do here. or you can use our services. We have a free service called the Inference API, which lets you deploy any model from the hub to manage infrastructure on Hugging Face. It's CPU only, and it's not auto-scaled. So it's great for dev and test, but not for production. If you want production grade deployment, then we have inference endpoints where you can deploy on managed infrastructure on Hugging Face, either on AWS or Azure, with auto scaling, CPU and GPU support, as well as different levels of security from fully public to fully private, where only you can access the model from your own AWS account or your own Azure account. We build that connection for you. Okay. Last but not least, we have partnerships with Amazon, or I should say AWS, on Amazon SageMaker, where Hugging Face is a first-party framework. You can just bring your own code and train and deploy using SageMaker infrastructure. And we also have a partnership with Microsoft, where you'll find Hugging Face endpoints on the Azure Marketplace. And again, you can deploy models in your Azure account in just a few clicks. Okay, so that's the final picture today. And, it's going to be growing, as you would expect. So let's do a few quick demos. I won't go into model training and so on, because this is kind of an intro talk, and you'll find more content on my YouTube channel and elsewhere. I want to show you some cool models just to give you a sense of what the state of the art is. So let me switch to my browser here. Okay. And let's just go through a number of spaces that we've built or the community has built, and see what's possible out there. So this one is about extracting information from receipts, as you can see, and it's using a model from Microsoft called Layout LM v3. And that's part of the whole, document AI topic, which is very, very important. Traditionally, you would run some kind of OCR on the documents, get some text, and then you would apply analytics to the text. We don't need to do this here. We can just run inference directly on those documents. So, using this example here, let me maybe open it, make it a little bigger. We can just predict all the items on that receipt. Okay. So it's a little difficult to see, but we have menu items, we have menu prices, etc., etc. And this is an off-the-shelf model. So, feel free to go and try it on your own receipts, or you can go and start from this model and fine-tune it on data set of receipts that you have annotated, right? How much code is this demo? Let's take a look. All these things, models, data sets, repos, spaces are Git repositories. So everything is open and accessible. So this one is, it's less than 100 lines of code. And, most of the code is really about drawing the bounding boxes, as we can see here. So there's more image processing than actual machine learning here. So there you go. This is actually one from my colleagues. Here's another one. This is based on the model called Donut, again, that you can find on the hub. And Donut lets you ask questions directly on documents. So let's look at this image. Here it is. Okay, so it's a conference schedule, right? So we see we have a coffee break and we have some sessions, and we can, again, instead of doing OCR and doing analytics, we can ask directly to the model, when is the coffee break? Okay, and it's going to analyze that picture, that scanned document, and it's going to tell us the coffee break is from 11:14 to 11:39, right? So again, this is a pre-trained model. You can go and try it on your own documents, and you could fine-tune it on any documents that you have laying around. So as you can see, you could say that's NLP, but it's NLP with a twist, because it's NLP applied to image documents, right? So let's look at another one. This is the one that I found really useful. It's a space built by one of our users. It's called YouTube Whisperer. And this is using the now famous Whisper speech-to-text model from OpenAI, right? So you can go and select the size of the model that you want to apply, pass it a YouTube link, and you can ask for the transcription. So the code is going to download the audio track from one of my YouTube videos here, and it's going to apply speech to text to it. And as you probably read, this Whisper model is very, very accurate, right? So there are some commercial services out there to do this, but you could actually use this completely for free, or build your own. So it's downloading it, and we should see the transcription. Okay. Oh, and that totally failed. Interesting. All right, let me reload the page. All right, I love it when it fails. Let's do that again. Yeah, it's the base model. It should work. All right. Yeah, let it download this. I'll switch to the next one. We'll come back to that. I don't know what went wrong here. Maybe my URL was weird. So here's another one which I actually built. This one lets me run voice queries on financial documents. So I took a bunch of annual filings for S&P 500 companies. I encoded them, and I can run semantic search using voice queries, because not only do I use a model for semantic search, I also use a Facebook model for speech to text. And the twist is I can speak any one of those 21 languages, which I can't, but I don't have to speak English. So let's go and give it a try. Qui est le CFO de Gap? Qui est le CFO de Gap? Okay, so the speech to text model is going to take that sentence. It's going to translate it to English. Then it's going to do speech to text and then translate it to English. Who's the CFO of Gap? And then it's using semantic search to query all the documents, actually all the sentences in all documents, to find the top matching sentences. And I can see I get the appropriate answer, and GPS is actually the ticker code for Gap. Let's go back to this. Okay, so this is broken. Fine, it was working 5 minutes ago. Okay, sorry about that. Okay, let's move on. And this one is, yeah, it's 100 lines of code. And again, you can see most of this is really building the interface and the samples. The actual machine learning part is just let's load the model and let's load the model and let's predict with the model, right? So a very, very simple code. And again, you can grab all of it. All right. Stable diffusion, I think we've already seen. And maybe we can do a final example where we combine Whisper, and hopefully Whisper is going to work now, and stable diffusion. So maybe let me reload the page just to be sure. And let's try and generate something here. Dragons flying over a castle in ruin. Fantasy matte painting. All right. Totally made that up. All right. Well, I got castles. And I don't see the dragons. Let's give it another try. Maybe I give it too long a prompt. Dragons flying over a castle. And it's going to generate something funny or silly. You never know. Okay, well, dragons and castles. All right. You can tweak the prompt and get better result than that. Okay, well, that's really what I wanted to show you. Just a quick run through some of those models and how they, how easy it is to work with them. I guess maybe just a final slide. This is the one you want to screenshot, I guess, with getting started with Hugging Face and transformers. staying in touch and links to some additional content on my social networks. And if your company needs help on adopting and deploying models and transformer models, again, we have commercial solutions for you to work with, from consulting to private deployment. So feel free to get in touch and I'll connect you. Okay. All right. Well, that's really what I wanted to tell you today. So let me give the screen back to our friends here, and I'm looking forward to the next presentation. And I guess we'll have time for questions at the end, right?
Absolutely, yeah, wonderful. This was just really impressive listening to you. I mean, new dimension for me that actually your model can go viral. That was fun. Yeah, it made me smile. But also incredible how much work AI can just do for us. Yeah, just in a snap. I mean, that's really incredible. From what you were showing, there's multiple dimensions. That's what I grasped. You have to correct me. That that are currently having an effect on AI, and adoption of AI are changing. Like you got the transformers, which are making it more accessible. The community. You get specific hardware designed for it. I mean, this is amazing. So,
yep.
Did I grasp this correctly? That you expect like an exponential growth of adoption rate, and us seeing much more of this?
Yeah, actually, adoption is not slowing down, and I should show, if I'm allowed to, I should show the growth of spaces. That would be a good one to show. You would not believe it.
Mm-hmm.
Spaces have been launched earlier this year. I think April or May, if I remember correctly, and it's beyond exponential.
Wow.
We see companies who are actually using spaces as their internal demo platform. So you can make those spaces private if you want to, private to users, on a group of users on the hub.
Mm-hmm.
And we've seen companies who actually adopted spaces and are using spaces just to showcase demos.
Wow.
Internally.
Mm-hmm.
So because it's such a great tool, no one wants to see models in Jupyter notebooks. If I show you I guess not stable diffusion, but if I show you speech to text or text to speech in a notebook, it doesn't look like it doesn't look anything exciting, and you won't fully grasp what the model can do. If I show you a space, it's obvious, and you can immediately project yourself in, if I added this thing to my app, I could build this UI and this UX, and it'd be cool, right? And so spaces is amazing. So, but you're right, the whole cycle is impacted, from models to hardware, for training to deployment. It's not just a collection of models. It's the whole workflow end to end that we're trying to disrupt and accelerate.
Absolutely. Yeah.
We have a couple of other questions coming in, Jan. Should we pick them up? I think one or two would go better right here before we come to the...
Sure.
Yeah, absolutely. Yeah.
It's actually going on the screen now, our back office. Very nice. Yeah. So as you read through, Julia, that was one of the questions that came up during your talk.
So it's a good question. So most of the models on Hugging Face are transformer models, but we actually have integration with additional libraries. So we have Keras models, we have scikit-learn models, we have about 15 to 20 additional libraries that work on the hub. So you can push a Keras model or a scikit-learn model to the hub, and you'll get all the bells and whistles there. And so, we're trying to, our machine learning philosophy of, treating machine learning just like software engineering, iterating fast, trying pre-trained models, etc., also applies to other libraries. And of course, sometimes you can combine. It makes sense to combine traditional machine learning with transformers. Transformers work amazingly well on unstructured data, but if you also have structured data, tabular data, probably you want to use traditional algos, and we're actually doing work on that. We have we're collaborating on a library called SKOps or SCOPS. I don't know how they pronounce it, where you can mix transformer models with scikit-learn models for increased effect. So sure, it's just use whatever tool works best, and if you combine them, sometimes you get good results.
Cool. There was another question coming in from Kevin, who asked if this space of Hugging Face is for all community, or is it just?
Spaces are wide open. They're completely free to use.
Mm-hmm.
You can create a space on the UI or just as a Git repo and that you push to the hub, and they're free. If you want GPU acceleration for your space, typically for computer vision like Stable Diffusion, it's a pretty big and hungry model, so it works much better on GPU. You can actually enable GPU acceleration, but that's a commercial feature. But anyone can create a space for free on CPU and host it on Hugging Face.
Very good. Okay, and one other question that came in was from Javier. Maybe we'll pick that up as the last one. Nope.
No, from Dirk. Yeah.
That's the one from Dirk. Okay. So first, thank you very much. I also want to join in. That was amazing, and I'm certainly not going to trust any more pictures that I see, whether they are real or not.
It's a problem. Yeah, it's a problem.
The question from Dirk, it's cut off at the end. That actually goes on where it says, when I then output it as text, it definitely needs an adjustment. How does it look here?
Mm-hmm. Well, it depends. I think that the general question here is, what's the accuracy of those models and how well are they doing? So the speech-to-text models, and I'm sorry, Whisper failed because generally I think the space is broken because the model is amazingly accurate. You can try it again 10 minutes. I'm sure it's going to work. Those models are trained on thousands and thousands of hours of speech with different speakers, of course, different genders, different ages, different accents. Because if you train it only, on 50-year-old French people speaking English, then it's going to do fine on that, but it's not going to do well with the German accent or the Indian accent or kids. So you need to have a lot of diversity in the data. So I would encourage you to test with your real life data. If you want to run this call center, for example, take 100 random calls and run them through the model, look at the transcripts and figure out, what works not best, what doesn't work. And maybe you need to fine tune a little bit. Maybe there's a particular accent that's not being picked up right. So if you can bring maybe 50 hours or 100 hours of calls with that particular accent, fine tune the model, it's gonna get better at it. But bottom line is you have to test with real life data, and those models are great, but sometimes they fail because your data is slightly out of domain and the accuracy is not there. But for speech to text, I found Whisper and those Facebook Wave 2 Vec 2 models to be really, really good.
Wow.
Okay, cool. With respect to time, let's take the other questions that came in onto our list, and we'll pick them up in the panel discussion towards the end, along with other questions. Thanks again, Simon. Really enjoyed the presentation.
See you later.
I'll see you at the panel.
Absolutely, yeah. So then let's welcome Oliver and Sönke on board here on stage. Wonderful. We got one. There we have two. Hi.
Hello.
Welcome back to this.
Yeah, Oliver, you've been with IONOS for many years now as well in your current role, head of big data and machine learning products, cloud. And Sönke, you're one of the founders of Stackable, and you have been working in the big data environment for many, many years. Also now working closely with Oliver, but maybe the two of you also give a bit of background for our audience.
Yeah, sure. I think I'll go first.
Okay.
Sönke Liebau, one of the two founders of Stackable. I've been working in the big data ecosystem or space for many years before that, which is also how I met Oliver. His title says it all, head of big data, so the link is fairly obvious here. And I'll be giving a demo of what we at Stackable do or try to do throughout the day and how it integrates with IONOS. And that part Oliver will probably take up first before I start my demonstration.
Yeah, really looking forward to that. So you're kind of working towards that adoption rate as well, like making it even more easier to get a infrastructure live, right? That's kind of what we're about to expect today.
Pretty much exactly what our mission in life currently is. Yes,
Absolutely.
it's getting open source tools up and running has been a nightmare for the past decade, and we are trying to make that easier.
Okay. Wow, then let's hand over to you guys, and the audience is free to ask any of the questions in the chat and at any moment in time, and we'll take it in after the talk or into the panel talk. Yeah, thanks. So enjoy.
So, and you might ask yourself, why big data? Because we've heard things around machine learning now. So I really love data, big data, but it usually has a problem. So real life data isn't too good prepared to actually really work with it. And yeah, of course, we would love to let the machines do all the work, and they can know everything and they can do everything, but I think we're not fully there yet. So talking about machines, for big data, there's specific tools that can handle data very well, that can be used for transforming data and for visualizing data. And yeah, that's what Stackable started some time ago, to provide an infrastructure which gets you started quickly in the area, and helps you to prepare all your data, to use your data, and actually to take it from various sources and put it into various sources. And one of them we've just seen is machine learning. So that is what Sönke will show you some introduction about how to actually use that. If you want to know more, I'll give you the screenshot slide first. You can have that managed. What Sönke will show you in a second. And if you're interested in more demos, then Stackable's website is your friend, and you can know more about Stackable with their homepage. And that was already the introduction. I'm here for picking up the questions. Sönke, up to you.
All right, I'll just share my screen. Hopefully, this worked quite well in rehearsal, so hopefully this works today as well. But if not, I can also just share the screen. So yeah, picking up or basically with what Oliver just talked about. What we are trying to achieve is to make it easier. It will probably never be easy to actually spin up these these big data systems. And over the past years, I've designed quite a few big data architectures or infrastructures for customers, and then quite often, like more and more, I have to say, the topics of AI or deep learning or basically all the sexy stuff that Julien just talked about came up. But what I've seen up until now, it is improving quite a lot. But so basically, my partner and I always used to joke. It's nice that all the cool AI toys are out there, but what our customers are actually worried about is ingesting a CSV file and converting that to Parquet and storing it into an S3 bucket or an HDFS cluster. So basically the stage that comes before you can train an AI model, which is getting the data, making sense of the data, sorting the data, storing it in a useful fashion, making it as accessible for the models. So basically all the boring plumbing, for lack of a better word, that underpins or that you need to get out of the way before you can actually do actual fun stuff with your data. And it sounds a bit weird, but that's what we find cool. So this is where Stackable is at home, and what we try to improve upon to make it easier to get the boring underpinning stuff out of the way, so that you can then start actually using your data and working with AI models on top of it. And what I would like to show today is something that we at Stackable call a demo, which, I mean, it'll become fairly obvious where we came up with the term in a second. So basically what a demo is it allows you to package your workloads, your infrastructure, the stack that you want to run it on, basically everything that you need to get up and running to actually process data and store it in a meaningful fashion in a single command. So if you go to the most of what I'll be showing today, you can actually just, if you want to click along at home and run it, if you have a Kubernetes cluster available. But like the specific demo I'm showing today won't run on your laptop because it's a bit too compute intensive. Well, depends on your laptop, obviously. But in principle, everything I do is public, and you can just follow along with what I do on the screen right here. So if you go to Learn and Demos on our website, this is the space where we sort of showcase the demos that the team have built, which, yeah, we're always on the hunt for open data sets that we can incorporate into one of these demos or multiple of these demos. So if you have any recommendations or would like us to see any use any data sets that you know of, please, by all means, give me a shout. We are constantly on the hunt for fun stuff to incorporate into these demos. And the demo that I would like to talk about today is our data lakehouse technology showcase, which I'll show the picture a bit larger in a second. Basically is a sort of vanilla data ingestion use case, I would have to say. Basically, you have a couple of, actually, let's maybe jump over to the picture and a bit larger here. You have got a couple of data sources that you would like to retrieve data from. So we have both of them are shown up here. So we have Pegel Online, sorry for the non-German speakers, which is basically a service that allows you to retrieve water levels of German rivers. So we have measuring stations all along the rivers, and you can retrieve data from those to see whether a flood is heading your way or for more useful use cases. And then Neue Mobilität, this is e-bikes, I believe, that you can rent, and you can check out what the charging state of those is and how many are on which station. So basically, lots and lots of German cities start publicizing or publishing more of like the data sets that they have available. And this one, I believe, is in Cologne. We can have a look at it in a second, which cities are hooked up here. So basically, this is for e-bikes. And then we also have the classic New York Taxi data trips or New York Taxi trips, earthquakes, and e-charging stations, like which cars are hooked up to which station pretty much. And then in the big data and open source ecosystem, it's always been, it's never just one product that you use. As you can see from this slide, in this case, we have 1, 2, 3, 4, 5, 6, 7, 8 products that need to sort of seamlessly work together to actually make this do something meaningful. So, and I'll show a few of those in a second, so I'll just briefly touch on them right now. So basically, you have NiFi, which is a ETL tool, I would say, which is that has been started, I think 15 years ago now by the NSA, and then open sourced at some point in time, which allows you to, in a graphical user interface, sort of configure, I'd like to take this, push it here, and do some transformations on the data. ETL. I probably don't have to explain that. NiFi then shoves all the data that it retrieved from the REST web services into Kafka topics. And then we have a couple of Spark jobs running, which take the data from that topic and do stuff with it. And of course, the stuff is actually the most important part of this entire equation. And that, I'm afraid to say, we can't make much easier, because that's so highly domain specific what you need to do there, that every customer will have their own people who will want to do that. So and that's then the sort of the border from infrastructure to actual like domain know-how, where you write your business logic that transforms data, joins it with other data, and then writes it somewhere that no provider can take that away from businesses. So and in this instance, it's really simple. It's pretty much just joining the station ID with where that station is, and give it making the measurements of water levels geo-aware, so to speak, so that we can visualize them on a map, and then writing all of that into S3 storage, which in this case is MinIO. Obviously, most cloud providers have S3 backends, but since we wanted this to be abstract, so basically what I'll be showing in a second, the demo you could run on pretty much any Kubernetes, and it would just work. And then Iceberg is something that takes care of merging files, compressing files, and then sort of just organizing files so that you don't have to take care of that. So your only job is to ingest data into the storage, and then Iceberg's job is to make sure that that is ordered in a way that makes sense. And the most fun part of the whole thing is Trino at the bottom, which is a query engine. So Trino, you then point at your S3, and it allows you to run SQL queries on CSV files or Parquet files or quite a lot of other stuff that you could potentially have in S3. And actually, it's not just S3. Trino has a whole bunch of connectors. A member of our team actually just extended a connector that allows Trino to run SQL on Google Sheets, because that's a thing these days. So basically, that allows you to hook up the Google Sheets that you have in your organization, and then you can make those queryable via a JDBC driver from Trino, which is a fairly niche use case, I'll admit, but we've encountered it and it's possible. So why not? And then Superset at the very bottom, we'll briefly look at that in the end as well, but I think for today it's much less important than for a lot of other demos that I've gave, which is a dashboarding tool that allows you to sort of explore your data and visualize stuff and basically just see what's in there, which during the development of AI models, I assume will be happening quite a bit, to actually understand what's in the data, what do I need to look at, and then how do I want to train the model on this. But I'm sure Julien will have some comments on that afterwards when we start the panel discussion. So yeah, this is basically all of this you need. Some of this is just configuration. You spin up the tools so that, for example, Trino finds the Hive meta store, which is just the sort of metadata of which table resides where. But for Spark, for example, you actually need to deploy source code, which says, I would like to connect to this and retrieve that and write it over here. And basically, what we try to do at Stackable is to make all of that work as seamlessly as possible, with the least amount of pain possible. So what we did is we created a whole bunch of operators, pretty much one per product that you see here. So NiFi, Kafka, Spark, Hive, Trino, Superset. There's an operator for most of these. Iceberg is a bit of an odd one out here because that's integrated into Trino in that case. And what we've also done is we've created a small tool that's called Stackable Control, highly inspired by Kube Control or Kube Cuddle, or I'm not aware of the current state of discussion, how the correct name for it is, to be honest. And Stackable Control, what it does is, I'll just briefly show it here in the terminal. Can that be read, or do we need to make the text a little bit larger? I'll just assume for now that it works, and people can let me know in the chat if you can't read it. So basically, Stackable Control tells you, well, obviously it tells you how it wants to be used. But mostly it has three main commands. One of them is release, and then you can list the releases. So this is now a stackable release. So stackable release 2211, which is I think we just saw that on the homepage, the banner up top. So this is our most recent release. And then you can say a stackable release describe 2211. And then it'll basically tell you release 2211 contains all these operators and all these versions. So if you now run install release 22.11, it'll give you these operators and this specific version, and we'll give you the promise that we've actually tested these and those versions together and that they work. But that only gives you the operator. So you have not deployed a single product yet. You only have the like our plumbing that would go and do the deployment for you. For the deployments, we then have what we call stacks. So the principle is pretty much the same most of the time. You can do stackable control stack list. And then you can already see, so data lakehouse, iceberg, Trino, Spark. This is probably the one that we deployed for this demonstration. And the stack then, so this now contains, all right, I want a Trino, and this Trino should connect to a Hive metastore. So I want that Hive metastore spun up as well. And that Hive metastore needs a PostgreSQL database to connect to. So all of this is encapsulated into this stack. And I'll show the definition of a stack in a second as well. And so if you deploy this stack, you actually have the entire environment that I've just shown spun up, but all of the tools are empty, so to speak. So no tables will have been created, no jobs are running, nothing is ingesting actually ingesting data. You'll have pretty much a white canvas to paint your own stuff on, but basically then you'd need to go log onto the NiFi UI, configure your flow, go to Kafka, create topics, create settings for those topics, all the stuff that plays together in actually like using these tools to create a meaningful infrastructure. And this is where the third step comes in that we created, which is the demo step. So if we do stackable control demo list, I believe, or demos, no, demo. So this is now basically this should hopefully match what I've just shown you on the website. So every entry in this list here should hopefully have an explanation on the website as well, which documents what it is, what it does, and how you can use it. And then if you now run stackable control demo install data lakehouse iceberg Trino Spark, which is what I did this morning because it takes like about 15 minutes to spin up, and I didn't want to make you listen to me talk about nonsensical stuff for 15 minutes just waiting for the demo to spin up. So I cheated a little bit. And then stackable control goes and installs our operators. It goes and spins up the infrastructure, waits for that to happen, and then it just deploys pretty much. A lot of this is scripted, I'll be quite honest with you. We are hard at work replacing most of the scripting that currently happens in demos with like actual proper code to make this configurable. But a bit of it is still bash scripts or Kubernetes jobs, like mostly people would also do to spin up these stuff in the normal world, so to speak. And then, as I said, you wait 15 minutes, everything comes up, and then you can do a stackable control services list. And this now gives you the actual endpoints that you can use to connect to the tools that were just spun up. So you can see we have Hive in here, Hive Iceberg, which is for technical reasons we need to spin up 2 metastores here. We have a Kafka, which doesn't have an endpoint we can actually click on because it doesn't have a UI. And the first one I would actually like to talk about is NiFi, which if we click over here, actually we can maybe just prepare this, of course. Oh no, I didn't. NiFi is the one I missed, sorry. So if we click on here and then head over here, this now allows us to log on to the NiFi website, and I guess it's still, yep, so it's cached my login from earlier. And then up here you can see this is a NiFi cluster with 2 nodes, and all the stuff that you can see on here is pretty much the graphical representation of the ingest workflow that I just showed you on the other slide. And this is a bit slow. I hope this makes it across fine, because my I think my laptop might be dying here in encoding the screen. But basically in here what you do is, so up here we have an invoke HTTP processor, so it goes and gets data from HTTP, then it splits the stuff, then it extracts your station UID, and then in here you can pretty much like join this with other data as well. And then the last step for most of these things is actually just produce these station records to Kafka. I just got a red pop-up on the stream thing that something went wrong. Am I still on, or did something like properly break? Still booking. Excellent. So I'll just continue talking. Yeah, so basically, this is what NiFi does. It allows you to, in a graphic way. Yeah, so basically, if you wanted to change this, you'd actually drag a processor on the canvas, and then you double click on it, and then you can configure things. It also has an API to deploy stuff like this in a programmatic fashion, which obviously, because the demo did it. But in principle, you can just manually click on here, and it's actually quite nice and usable for getting quick results, ingesting data. And then moving on in the picture we looked at, so NiFi writes all the data to Kafka, and then Spark is the tool doing the actual heavy lifting. And if we head over here, I believe, yep. So this is the Spark job doing the ingestion. And if we head over here to the structured streaming page, you can see that there's currently 5 streaming queries running, which in regular intervals will query the REST interfaces that I looked at earlier. So you can see shared bikes, then the water level stations and water level measurements. So some of these APIs have different endpoints that we need to all connect to and gather the data, because we then need to join that before we write it out to the deep storage. So there's actually more than one ingestion job running here per REST endpoint. And then Spark does its thing in the background, matches data, joins data, queries data, whatever your business logic requires. So this is the part where there's no right or wrong. Every user will have to find out for themselves what their specific needs in this instance are. And then pretty much just writes the data out to the S3 bucket, where Trino goes and queries it. So Trino doesn't have any oh, sorry, let's maybe jump to the overview for a second here. So basically, it all ends up in here now. And then Trino comes along, and Trino is the query engine, which does its thing in the background. So the UI isn't anything special here. We'll head back here in a second once we've actually started some queries, and then we can hopefully see what's going on here. But the thing that we can actually use to have a look at the data and talk to the data is Superset, which is, I mentioned it earlier, it's not a BI tool. That would be would be too much. It's more of a dashboarding tool. So basically, it allows you to create colorful charts out of the data that you have stored in your S3 buckets in this case. So we have a few dashboards that are available here that we could, for example, look at. I think house sales, for example, is the UK publishes prices for sales of properties every year, or actually every month, I think. And that's quite a nice data set to look at. So over here you have the average price of so how many houses or properties, doesn't have to be a house, were sold, and what the average price was. And you can actually see that 2008 that went down quite a bit, but it actually didn't affect the average price, for example. So I was quite surprised to see that. And what you can also see is that in the UK, buying a house in London is quite expensive. Actually, it's so expensive that on a heat map of the entire country, the rest doesn't even show up if you have London on there. So if we scroll a bit further down somewhere when London isn't on there, then you can actually see that so basically this is the average house price, shown on the chart. So in here you can see where in Manchester, for example, you could buy a house cheap-ish, probably not going to be cheap. But yeah, so basically this is just a tool that allows to explore your data, draw dashboards. So dashboarding is probably the most commonly used functionality of this, but just by building these, you can learn quite a lot about your data, which is, to my mind, very important to then actually working or finding meaningful ways to work with the data. So this is actually quite a nice tool to just get to know your data a little bit. And if we now head over to maybe show the finished queries here. So basically here you can see all the queries that Superset sent to Trino in the backend to actually then get data to generate all those fun charts that we just looked at. And in the back, it's going to be a little bit technical now, but I'll keep this short, and then I think we can move on to the questions. I've lost track of time, to be honest, but I think we're probably nearing the finish here. So what happens at the end is, as I mentioned, all of this is running on Kubernetes. So what we did was we wrote a bunch of operators to do this. So you can see if we filter this by operator, you can see up here is our basically a running pod per operator from us, and then in here we will find a lot of pods. So here you can see all our 4 Trino workers that have spun up on the cluster. And if I now went and changed anything in the definition of that Trino cluster, like for example the Trino version that I want to be deployed here, then what our operator would do is it would react to the change in my definition of infrastructure, check whether the pods out there match the version that I want to be running, and then it goes and makes changes to all the things in Kubernetes so that what I've specified should run actually matches what is running in the cluster. And that's a quite nice thing, I have to say, because back in the day, like before Kubernetes existed, all these open source tools also were available, and they are deployed by tools like Cloudera Manager or Ambari, which Hortonworks has. Hortonworks, sorry. And all of that took quite a lot of custom code to actually run building interfaces, and Kubernetes takes away a lot of that, again, boilerplate that's needed to deploy all of these things. So we are, while we do fight with Kubernetes on a daily basis, we are also quite happy that it exists and takes away a lot of the complexity that we would have otherwise had to solve ourselves. And yeah, basically that's what I wanted to show today. Maybe Oliver can rejoin me for some Q&A time.
Wow, absolutely impressive. I'll just use Nicola's word from the chat from LinkedIn, and he said it's utterly brilliant and brilliant talk. So really, really good.
Thank you.
Okay, it gave me a very good feeling on how you can practically get all this new tech live, and it was really good to see.
Yeah, thank you very much. Do we have specific questions we should pick up right now, or are we going to move into the panel discussion right away?
I think we should maybe. Or Sönke, I just interrupted you.
No, sorry. I was just about to say that I didn't have time to look at the questions while doing the demos, so I would just start picking them now. So
all right. Well, then I would suggest let's head right into the panel discussion. Usually we have a slide that comes in to give you a bit of time to do makeup. I did my makeup already. It was really getting dark here, so I brought a light here.
Absolutely.
To be a little brighter here. It's not AI technology; it's the actual real image you can see here. Yeah, and then I would say let's welcome back Simon on the stage as well.
Hello, there we are. Okay, explaining the. Yeah, Heiko.
Yeah, there was one question that just came up from the chat. Maybe we'll pick this one up, and then also the answers to the one before. So this one for Stackable, are you thinking about using Apache Flink in the future as well?
Yes, we are. So it's been asked for by customers, just never in a not forcefully enough so far. And for us, it's our we've been using Spark. We've been using Spark all our lives. Sounds a bit weird, but we are more used to Spark than to Flink when we started on this journey. And since we already had Spark, then Flink was a bit of a not a duplicate, but it sort of serves a similar purpose. So we are constantly re-evaluating or evaluating whether we want to add it. It's not made the cut so far, but I'm not saying it won't soon-ish. That's a bit. So we consider the entire stack to be ever evolving, so to speak. We'll try and move wherever the community moves with the tools.
Very good. And then I think we had an issue not being able to respond on LinkedIn with the comments. Simon provided some answers to the questions that came before. Maybe we want to pick those up real quick. Jan, you have them on your list, I think.
Yeah, absolutely. So Javier, you asked how the community was doing on creating big models. So maybe just want to repeat your answer then here for the whole community on LinkedIn, which wasn't able to see their written response. Julian, that was for you.
Sure. So, so I think generally the community is doing very well. In fact, Bloom and Stable Diffusion are a reaction from the community to companies trying to close similar models, and I think that's a very healthy reaction, and it's a strong warning to companies who could be tempted to close their research, that they have the community, who's not going to accept that, and who can literally in a few weeks come up with open alternatives. So like I was saying, I'm pretty confident and pretty optimistic that the state-of-the-art models will stay open.
Maybe just along that line, I mean that's also what our CEO always likes to say, is like kind of that open source already always outruns these closed models. Is that kind of, maybe you have some thoughts on that as well? I mean, specifically from Hugging Face, that's your kind of
and machine learning research is open. Those models are published in research papers and discussed by at conferences. So by design, this thing is open. So then, of course, you could publish the architecture, but you could refrain from publishing the actual code and the actual weights. But I think that's a bad move. I think if you, as a researcher, if you want adoption, if you want recognition for the great work you've done, the best way to do this is to put that stuff in the open. Obviously, corporate interests can stand in the way, and we've seen some examples of that. And as I've said, the open source and the research community has reacted very strongly and very quickly. So and we see companies sharing more and more. I mean, Google typically and Meta are sharing amazing large-scale models, even in the last few days. So I think they see the value in sharing and demonstrating in the open that they're machine learning leaders. And of course, they can use those models internally for their own services to build cool stuff and make money, and that's okay. I mean, we need to make money too, but I think you can make money with open source and in the open, and I think that's where everybody wants those technologies to go.
Good point. Yeah, absolutely.
I think picking up on open source is a good thing. We hadn't talked about that, but Stackable actually is also an open source company building on top of open source and being open source by itself.
Yes, absolutely. I just noticed that we completely missed that in the presentation. That's right. Everything we are doing is open source as well. And I think, Julien had a great last sentence there. We do need to earn money, but that's possible with open source. And there's many ways of doing it. We've seen struggles in the open source community over these past 3-4-ish years, I would say. Like lots of products becoming less open, moving away from like accepted open source licenses to code available licenses. So I don't think the perfect business model has been found yet for open source, but I do agree that open source will always be better than anything closed. Like taking the Google Sheets Trino example I just had in the demo. The connector actually didn't do something that the customer needed, and I think it took our employee like 3 days to implement that, and it's just about to be committed upstream, I think. Okay. Good luck going to someone like AWS and asking them to implement new technology in one of their products in any similar time frame, I would say. So open source, I love open source and seeing how stuff works. So I always prefer it over anything closed, to be honest.
You mentioned it took some time, or the community had a little bit of a hard time up until now. What changed? What do you think?
Good question. I don't think I have a good answer to it. I think open source software became more prevalent. Like back in the day, it used to be that there was Linux, and that was the most talked about open source project. And then Postgres, Hadoop came along. Hadoop, I think, actually paved a bit of the way. So I think it just became more prevalent. I mean, like 8-ish years ago, I had a customer and they had a strict no open source policy. Nothing that was open source was allowed to be run on their premises. And I don't think companies like that exist anymore today. So it's just become more commoditized, maybe, for lack of a better.
Yeah, good point. Yeah. Okay, taking up from that, anything else you learned from the other one's talk? That might be an interesting question. To bounce that at each other. Julien, maybe you want to start. What did you take away from the presentation?
Well, big data is the foundation on top of which you can build machine learning systems. Sometimes I speak with customers, and 3 minutes into the discussion, they want to talk about neural networks and the crazy models, and I ask them, respectfully, to step back and explain to me what their data infrastructure looks like. And it doesn't matter if you're using images or speech or tabular data. You need to have a way to store, clean, label, extract, transform, secure the data. And if those pipelines, from the source applications all the way to your data lake or whatever data repository you have, if that stuff doesn't work, and if you don't have the data engineering platform to produce data sets from raw data, there's a huge difference between data and data sets. That's a different talk. Actually, I should build it. But seriously, if you don't have that stuff in place, please build this first, and then we'll talk about machine learning. Just like if you don't have CI/CD in place, why are you even deploying anything? It's a disaster waiting to happen. Build your pipelines, build your automation, and then you can go up the stack. And I think what Sönke demonstrated is exactly that. You need to go and be able to grab data in whatever format it is, and then transform it and clean it and visualize it. I really liked the heat map stuff. And then once you know what that data looks like, and once you build confidence that, oh yeah, this is what kind of what I expected to see. This is interesting data. Now, what can I predict with it? And then you can talk to me. But I think those are two sides of the same coin. And machine learning is sexy and exciting, but you need to pay your dues. You need to do the homework, and the homework is a data and a big data and a data engineering platform, and that's what we saw today.
So,
sorry, you go first, Heiko.
Yeah, I have to ask this question. So I have two kids. They're 19 and 22 years old. And if I look what they've been doing in school, and then I look back at my early days when I was young, when I was studying, the internet was basically invented. We had the first emails written and started to create HTML pages back then, writing plain HTML code. Today, the kids in school, at least the generation my kids, they work with various tools that would have been unimaginable, building websites with WordPress, doing presentations and all that stuff. So listening to the two sessions today, seeing how easily you can pull up a big data infrastructure and how easy you can, work with models without having to create them yourselves. Do you think the next generation of kids in a few years will basically start in, grammar school or even elementary school working with machine learning models to do whatever fancy stuff?
Well, if you look at, last year, right? Let's just go back a year, and before GitHub Copilot. And I'm not a GitHub evangelist, and I would prefer to have an open model, and I hope Big Code becomes that. Still, I'm amazed by Copilot. I actually did a YouTube video where I'm writing Hugging Face code with Copilot, and yeah, you can go and take a look. And I'm just prompting it and accepting. And I literally almost write the complete notebook just with the prompts. And I saw today they're announcing a voice feature when now you can just speak the prompts and it generates the code. So I signed up for the preview. I don't have access yet. I think it's. Some of you out there may have kids, and you may have played Scratch with them, right? Scratch is a really great tool to learn algorithms and the basics of programming. So I'm thinking, very soon, before we know it, we'll be building complete business apps with a Scratch-like application. And code, writing code from scratch is going to be a thing of the past. I'm sorry. No one wants to hear this. It's an unpopular opinion. Writing code from scratch is going to be something outdated pretty quickly, except for niche domains like embedded programming, which is very, very particular. But even that will be affected. And I think even building apps will become, like playing Lego, right? Assembling things, and just assembling APIs, assembling modules, or even letting AI models figure out what models you should use, etc., etc. Wait for the model that generates full UIs. That's got to be coming. I'm waiting for that one. Building full HTML, React, whatever code from prompts or mockups. That's coming. It's obvious. So I think, it's going to be very, very interesting times. And it's not 20 years. Okay. I can guarantee that.
Sönke, Oliver, you share that vision as well?
So it's already interesting at school. So my daughter actually learns computer science with Scratch, which I think is really cool. And we need those cool computer science teachers and which take that tools into the school. And our school system might not be perfect. It's teachers taking that into, and I think if the AI adoption goes the speed that it went the last years, I think that'll come to school too. So our pupils will be digitized before the school system is.
I think speech to text, or text to speech, right? I mean that's an easy one to add. I mean, like adding speech to text in Scratch and building your program with voice commands. Why hasn't anybody built this? Or maybe it's out there. I need to test the latest Scratch versions. But yeah, I think we need to educate people and help them realize how powerful the technology is. I think that's great. And yeah, the more students go into that, the better. We need more.
So
okay, and coming back to Stephen King's original statement, which direction are we going then? Is that good? Is that a positive development you see, or do you have concerns?
It's like everything else. It's not, some people want to sell you the apocalypse because that's the book they have on display. Some people want to sell you the magical rainbows and unicorns future because that's the book they have on display. I mean, I don't have a book on display. I'm just an engineer, so I'm balanced. It's like the combustion engine, and it's like nuclear energy, and it's like anything, biotechnologies. I mean, you can save lives, you can destroy lives, you can do both. And generally, we do a bit of both because that's what humans are all about. So AI is amazingly powerful as a technology tool. You can see, I mean, this deep learning thing is not even, I mean, from a practical perspective, it's not even 10 years old. And look how fast we've been moving, right? So imagine 10 years from now, 20 years from now, how we can accelerate and workflows and build stuff that's just, you know, accessible to everybody out there and not just experts, whether it's looking at medical images or translation or et cetera, et cetera. So there are some risks, there are some challenges. One risk is this technology being captured by a small group of corporate entities. And a few years ago, I was more worried than I am now, to be honest. I think now there is such a strong community that we can probably resist those groups. And then, of course, you know, you have risks like pretending those models are intelligent. They're not intelligent. Only humans are intelligent. Those models are really good at computing very fast and picking up very complicated patterns, but they're only as good as the data they've been trained on. So bias is a problem. Hallucinations are a model. There's this whole discussion on models hallucinating, which is producing data that's just completely wrong. That's completely out of domain, producing horrible images that are nothing like what you ask for, or text generation models generating stuff that's correct English, but it's not at all what you wanted. So those models still have no common sense and they can go wrong. So we need to be aware of that. But yeah, I think we need to work on those. Like every new technology introduces challenges, and each challenge becomes a project in itself for engineers and researchers, and we need to work on that. So we should be just, keep stay level-headed and have a clear mind, not get high on our own supply of technology, realize this is cool stuff, but something doesn't work sometimes. So let's figure out what it is, let's fix it. And that's how you advance the state of the art. So and more than anything, don't listen to people who have books to sell.
Yeah, except the one that I was actually mixing up. Speaking of clear minds, I was informed I accidentally said Stephen King instead of Stephen Hawking. Almost the same, but
almost
easily mixed up. Yeah, absolutely. So Sönke, you also wanted to share a perspective on where this is going towards the kids at school. Please do.
Yeah, absolutely. Thanks. So I can't really talk about kids in school because for me and my wife, the big question currently is whether or not to send out to school next year. So it's a bit early for us here, but I'm looking forward to how it is in 4 to 5 years when he comes to the relevant levels. But yeah, I don't disagree with anything that was said. I just wanted to take a little bit of a different perspective, maybe, because yes, we do have code generation from speech and fabulous AI models and all that stuff, but at the moment, or in principle in technology, all we're doing is we're adding more layers of complexity on top of stuff that's already there. So AI runs on serverless, which there still will be a server somewhere. And then so basically then AWS has something that provides that serverless function. And somewhere at the very bottom, there'll still be an 80-character terminal somewhere, because this stuff doesn't go away. It still exists. And my personal opinion is that people will still need to be able to use this. And there was a fabulous article on Hacker News a couple of years ago, I think, about the dark matter programmer, it was called. So us, simply by being here and talking about cool technologies, we are sort of 1% of IT, I think. For each and every one of us, there's probably 99 people out there doing the actual work. And actual work is probably in an Excel spreadsheet or something with little basic applications from in a version from 10 years ago because corporate didn't update it. So that stuff is still around, and it's what makes the world go round, I believe. So we do still need to be able to understand and use. And sort of going back to something that Julien just said about big corporates controlling the models or the cool technology. I'm with you. I don't think that that's going to happen. I'm much more afraid of a few big corporates controlling the hidden complexity, like we currently see with AWS, Google, and Azure being the ones providing cloud services that everybody uses and locks themselves into, because no one wants to actually like run a server anymore where they need to take care of updating the OS and then pulling out a disk and putting in a new disk and stuff like that. What we grew up with, pretty much. So that being commoditized and provided by a few large corporates, that's what I'm afraid of and what I'm currently seeing a trend towards, to be quite honest. So that's maybe a bit of a dark perspective.
Yeah.
Sorry for that, but that's the other side of the coin that I see a bit.
But it is actually a good handover to a question that came in through the chat. Where do you see the biggest potential dangers in artificial intelligence? That's a concern that you just raised, Sönke. Do you or also Oliver and Simon, do you see real danger coming up as well, or is it really just putting it into some kind of dark perspective, if you want?
Well, if danger means Terminators, I mean, come on, right? I'm not. I'm not seeing that happening. And Terminators are robots, and for some silly reason, people tend, I guess, because of magazines, people tend to mistake, AI and robots as being the same thing. And okay, these are completely different things. So, no, I don't think Terminators are coming anytime soon. No, Skynet is not going to exterminate humanity. I think, if anything, we have proof right now that we're very well capable of doing this ourselves with ancient military technology. So we don't need AI to cause a lot of trouble and put everybody at risk. But I would say from a more fundamental perspective, I think, like I said, the top risk is this technology being confiscated by corporations or a technical elite, and that's why I spend most of my time presenting Hugging Face and educating developers, not machine learning specialists. Right? Machine learning specialists, they don't need me. They know the stuff. They know the stuff better than I do. But my purpose here is really to educate, I would say, normal developers, and I mean that in a very positive way. I consider myself a normal developer. I don't have a machine learning PhD. I never wanted one. And of course, business users on what is machine learning, what is AI, what can it do, what cannot it do, and show how to get started. And demystify that thing. It can get crazy complicated, sure, if you dive into the lower layers of AI and ML. But for your average company out there, your average organization, you can build cool stuff, like I showed you, right? And it's not complicated. It's a little bit of Python. I didn't show how to train models, but you'd be surprised how straightforward this is as well. So the big risk is not having enough people joining the party and making this a closed party for a few big corporations and a technical elite. That's a big risk. 10, 20 years down the line, because if you let them confiscate this stuff, then human nature will lead us to a dark place.
Okay. Kind of going down that direction, we talked about making it easier to use the models or program at all and make it inaccessible even more. And maybe this is an old story, but that was a kind of a fun one for me. It was in Amsterdam, and they had this presentation, and they taught an algorithm to identify wolves. And they actually showed it a wolf in summer, and then they found out they had a snow detection machine, right? This is just funny in some sense, but that's probably not well practiced. So maybe just, if more and more people join the party, maybe be useful to give them some hints or tips how to prevent, this kind of errors to happen.
Yeah, like I said, this is the whole common sense discussion. If you show simple pictures, animal pictures to a 5-year-old, the kid is going to do just fine. And for a machine learning model to do the same, you need hours and hours of GPU training. And sometimes, if you take a cat and paint it with orange stripes, it's going to tell you it's a tiger.
Yeah.
And I mean, even a 5-year-old would pick that up. So that's why I'm saying that's not where the risk is. These things are never going to be intelligent the way we understand it. And it's really about understanding how those models work. And they're just statistics, computing things and outputting probabilities. And we need to understand what the probabilities mean. And we need to be very, very careful about the data that we feed to those models.
Yeah.
Because, like I said, if you feed, to a speech-to-text model, if you only feed, American voices, then what happens when you try to use the model in India or in South America? It's not working, and that's a problem. It's that technology should work for everybody out there. Everybody should benefit. So, again, the diversity of the data should reflect the diversity of the users, and that's a very strong concern. And there's a lot of work being done here. I mean, I think we're all aware of the problem, but data sets today are what they are. So a lot of them are not perfect. We need to understand how bad they are sometimes.
Yeah.
And when we build new data sets, we need to be really careful that there's enough diversity in there. Like we're doing, in the data sets we used for big science and the one we're building for big code, as much difference as possible in there, because that's what the world is, and if you want to apply the model in 180 countries, it needs to work for everybody out there.
Yeah. So there was a question coming in from Paolo asking if there are any other areas you would see that are disrupted by AI over the next few years. We talked about education earlier. Oliver, is there another area that you feel is going to go away, change completely?
So I think we saw it in Julien's presentation. In future, no one will read receipts anymore, even print. So I think printing is already wrong, but reading them and writing them by hand or into a computer again, that's just something that needs to go away. And I don't know if someone wants to do that.
Yeah. I just had a recent exposure to the German health system, back into fax sending and manual paperwork, then scanned in or not. So way to go to make that all become digital. But that's certainly impressive.
Yeah, I mean, I would return the question and ask, which area isn't being disrupted by AI today? And of course, we could discuss the level of disruption, but we work with customers across the board, from life sciences, financial services, manufacturing, retail. Every e-commerce website that you see is using recommendation, right?
Yeah.
And that's machine learning, and transformers can actually also be used for recommendation. Chatbots, voice assistants, autonomous driving, energy prediction. That's going to be an interesting topic in the next few weeks, right? Let's see if the forecasting models work, or let's see if we need to buy extra sweaters and firewood. And I know, Germany and France have similar problems there.
Yeah, I just did a forecast of my future prices.
Yes, exactly. So it's finding its way. I mean, machine learning is finding its way everywhere, because we have data everywhere. And I hear you on paper forms and red tape. France invented that. So we're making very slow progress on digitizing services. If you look at other countries like Estonia, I was in Estonia a few years ago. I don't know if anybody from Estonia here, but I envy you so much. The level of intelligence and digitization that you have across the country is just the world's golden standard. So we just have to follow your example. But again, it's finding its way everywhere. We have text data everywhere. We have images everywhere. We have forms everywhere. We have speech everywhere. So there are just plenty of untapped opportunities to build smarter, faster, less expensive business processes. And that's why we want everybody on board. Everybody here can think of use cases in their own organization. So just go for it. This is what we need to do today.
Absolutely. I couldn't agree more. And then because we're running out of time, we'll take that statement as our final statement. Thanks a lot to you. Yeah, wonderful. Wonderful having you here. There's one last more thing that we usually have here for the books, because this is session 6. And yeah, we usually do a smile, a selfie here. So maybe everybody kind of get the hair right, and then we'll have one for the memories. Yeah. All right. Okay. 3, 2, 1. There we go. Probably have the picture. Thanks a million from my side for the talk. I could have listened like ages to you and even continued this talk here, but well, we're running out of time. So I'm really, really sorry. And I hope to see you very soon again.
Yeah, thanks from my side as well.
Thank
you so much. And for the audience, all of the presentations, the recordings will be available later on online as well. So if you missed something, you can rewind. And that's not even AI, that is just a recording, which we'll put up there, right? I think the AI is actually what I found recently in a chat tool, where the chat tool now provides a summary of what is written below in many messages. That is a cool use case.
Summarization models, yes.
Yeah. So thanks very much to our guests.
I found out they're not good at identifying sarcasm.
Oh yeah, well,
yeah.
That's always a challenge.
Or something.
Humans are humans.
Humans.
That's fine. That's fine. We need to have an edge at least on a few things.
Yeah.
Wonderful.
Thanks, Oliver.
Cool.
Thanks, Sönke. Thank you, Simon.
Thank you very much
for joining. And we sure hope to see you around, all of the guys and ladies and gentlemen, in the online streams whenever we do the next session that will be coming up at some point. But first, we are going to take a little break for the winter, right?
Absolutely, yeah. We're kind of closing it off for this year, and then come back with the event in next year. So it was absolutely great audience here. A lot of questions. This has just been lovely. I'm really looking forward to our next session. Yeah.
All right, that's it. Let's see what we'll do next with whatever AI comes up to change our lives.
Yes, and
bye-bye.
One last more thing. One of our colleagues in the background, which has been a lovely assistance here, Xenia, will post a feedback link in our different platforms. So we'd be really appreciating feedback from you guys about how you liked it, what we could have done better, or anything you want us to talk about or invite guests about here. It's probably not our experience.
Yes. Very good. Thanks for the reminder. I'm switching screens back and forth, and I missed that one. Yeah. Thanks for your feedback. Anything you can share with us will help us improve for the next session. All right.
Take care.
Stay safe. Stay healthy. Bye-bye.
Bye.